Hello there, my name is Luqman Owamoyo from Nigeria. I'm a master student at OKAN20f Istanbul, Department of Architecture. I'm here to present my semester project, Building Architecture in High-Rise Buildings. Let's get into it. Through the ages, shelter has always been defined as space that shields and houses living organisms from the harsh weather conditions of their natural habitat. Over the years, shelter has evolved to offer more than being a space to lay one's head after a hard day's work. It needs to offer a comfortable and relaxing environment. This cannot be discussed without talking about indoor environment quality, which is a phenomenon that determines the comfort a living space has to offer. Good indoor environment quality is achieved by creating a space where factors such as ventilation, thermal comfort, acoustic adhere to the human body conditions. While natural ventilation can be used to put most of these factors in place, it is however thwarted by limiting issues such as wind speed and direction, building orientation, size of openings, outdoor temperature, and design requirements. This has led me to research on the concept of breathing architecture, which employs structural and aesthetic strategies to maximize the flow of natural air. Natural ventilation, which is a method of supplying fresh air into a building, can be achieved in two ways: wind speed and thermal buoyancy. By placing openings towards the windward side of the building, air can be introduced into a space and used air can be expelled through openings on the leeward side. This is the basic definition of achieving natural ventilation through the use of wind speed. The second way of achieving natural ventilation, which is buoyancy, is in two ways: temperature induced and which is stack effect and humidity induced. Buoyancy works on the principle of difference in air densities. That is, as air itself in the space, it becomes lighter and rises. This is then replaced by cool air coming from openings. The heated air is then expelled through openings in the roof or chimneys. As easy as natural ventilation sounds to be achieved when designing a building, it actually comes with some limiting features such as wind speed and direction, building orientation, surrounding environment, opening sizes, outdoor temperature, and design requirements. Because of these limiting features, this has led most of the world population to push for mechanical ventilation systems. But recently, it has discovered that mechanical ventilation systems cause harm to the environment. They release harmful gases, carbon emissions, which clog up the Earth's atmosphere and deplete the ozone layer, and this leads to global warming. Now, I believe the concept of breathing architecture can be used to harness and improve natural ventilation. By doing this, mechanical ventilation systems can be done away with, and the earth becomes a better place to live in. Breathing architecture can be achieved in many different ways, some of which are responsive components, pneumatic facade technology, kinetic facades, wind towers, building envelopes, breathing and double skin facade, extensive use of greenery, shading devices which can be operatable manually or automated, then breathing and tomb walls. While researching for this project, I was able to come across several architectural projects that have made use of the concept of breathing architecture in some way or the other. This actually led me to the second part of my article, which is the matrix. As you can see, I've been able to list out the buildings which I'll be doing a case study on, and the features I'll be looking at on each building are ecological criteria. Before I can do that, I've been able to itemize the city each building have been built on, the architect who made them, the year they were made, total area and size, speed of use, as in the building use, building materials, water use, water recycling management, energy efficiency, renewable energy usage, biodiversity, shading devices, measure against solar heat gain, then green area and hard floor proportion, accessibility to the site, and at the end I was able to make some SWOT analysis on each building. Itemizing the strength, weakness, and threats that each building offer to the environment. I'll be talking about a few of them. One of which is the Met building in Bangkok. It was designed by Wo Architects in the year 2009, and it covers a land area of 11,360 meters square. The Met is an advanced form of high-rise building, which consists of living apartments for the population of Bangkok, and it incorporates typical tile elements such as ceramic tiles, step tiles, and timber paneling. Now, for the waste recycling management, they have in place garbage bins for waste separation in public spaces and GMA bins for hazardous waste. Now, during the course of my research, I've noticed that each building have put in place measures to take care of energy efficiency. That is, they've put in place measures that is going to make them reduce the cost of energy and conserve it. As for the Met building in Bangkok, most of the spaces in the building have cross ventilation. Now, since cross ventilation is available, the need for mechanical air condition is eradicated. And in the Met building, they have solar panels on the roof, which is used to trap solar heat gain and provide electricity for the building. Now, for the shading device, the wall building has overhanging ledges and perforated metal screens. This in turn helps to conserve the interior by shading it from solar heat gain and keeping it cool. As you can see here on the outskirts, that's where we have the vertical layer, the overhanging ledges, and the metal screens. Now, I was able to get some strengths and weaknesses from the building. One of the strengths I was able to get for the building is that for each apartment, they have a personal planter in which can be filled with greenery, and they have wind towers to help with expelling hot air through the roof. Some of the weaknesses I saw from this building is that there is no water recycling units, so they have no measures in place to conserve water. And through the planning phases for the opportunities, a water collecting roof can actually be implemented. And that building I'll be talking about is the Bloomberg building in New York HQ, which was designed by Foster and Partners in the year 2017. It covers roughly around 102,000 meters square. It's an office building for the Bloomberg Corporation, and it's made with structural sandstone frames and bronze frames and wood. Actually, while I was researching for this case studies, the Bloomberg currently holds the best percentage in the BREEAM rating in the world. It's a building that has tried as much as possible to reduce energy cost to the barest minimum. It has water collecting roof, and it's put measures in place to collect grey water from sinks, which can be reused. They have for the energy efficiency, they have integrated petal design ceilings, which open up to let hot air flow out and smart air flow. So, and for the renewable energy resources, it's funny and it's interesting with the way they deal with reusing energy in this building. Non-degradable waste such as keyboard cables are used to make artworks that workers can experience in the building. Then on-site water treatment plants are in place to reuse water from airline style vacuum toilets, and then they have solar panels for electricity. For the shading device, as you can see, they have this bronze fence right here, which shields the interior of the building from the solar heat gain, and it helps to block the interior from heating up. Now, this fence are actually movable and can be moved when outdoor situation is suitable to make maximum use of natural ventilation. And as for the strengths and weaknesses too, I was able to itemize that. Sustainable design by the use of bronze frames to control light, as water collecting roof, and on-site water treatment plant. And another building I'll be checking out is the Istanbul Sapphire, which I'll be talking about. The Istanbul Sapphire was designed by Tabanlioğlu Architects in 2011, and it covers roughly 165,000 meters square, and it's a mixed building It consists of commercial centers, for the building rentable office spaces, and residential apartments. Uh, the building was made with concrete, steel, and glass, and water to the building is got into the natural grid, so the building has no water collecting feature on site. Then they have low lighting cost because of the glazed facade that features a double skin, and it is at this double skin that we have the vertical gardens, and it's the double skin helps in reducing noise pollution, and it serves as a buffer zone for the heat exchange. Energy use is reduced in this building because of the sufficient amount of cool air the building gets through stack effect. Um, I forgot to mention, but the double skin facade, the space between the outer skin and the inner skin, also serves as windows for the building that helps in expelling hot air or heated air through openings in the roof. Oh, um, the building has vertical gardens on each residential floor. This will help in cooling the interior and ensuring a comfortable living space for the inhabitants. As you can see, here is the double skin facade. We have the glazed outer skin and the inner skin. Then scrolling down, we can see the section of the building, and as I mentioned earlier, the double skin facade that helps in um, taking in cool air and expelling hot air through the roof. As you can see, we have this large space right here, and the vertical gardens that are on each floor. The strengths and weakness of this building, and the double skin facade serves also as noise filtering, shading space for planting greenery, stack effect wind tower, and heat gain reduction. Finally, as a conclusion, having made case studies on this building and come up with a SWOT analysis on them, I should be able to come up with a building architecture model that will be used in my proposed design, which will focus in a tropical climate. I believe the concept of building architecture will solve the problem of indoor environment quality by causing little or no harm to the environment and build energy efficient buildings that make use of renewable resources. To get a better grasp of the design technique to employ, I'm going to make a site analysis of the land area I'll be designing my building on. Conditions such as climatic, atmosphere, sun and wind direction, site topography, and section will be studied. Now, following this analysis, it will help guide my design technique. I propose to have ecological features such as vertical gardens, which will be placed in my design to improve the indoor environment quality, and outdoor green features is also being in place. And for most of the buildings which I made a case study on, they have um, no measures against noise pollution. I shall be providing a solution for this as well. Then make sure the building is sustainable. Renewable energy resources, which are very important aspect of design, will be implemented in my design. Welcome to the design part of my project. I'll be taking the site from Lokoja City, which is a city in Nigeria. It is the capital of Kogi State, and it is regarded as a confluence town because this is where the River Niger and the River Benue meet. It's a business city with trades in agricultural and aquatic produces, and the site is bounded by social facilities to the north, River Niger to the right, and access roads to the left. For my site size, the site is roughly 19,000 square meters, and I believe this will be enough to have the features such as water treatment plants, parking areas, adequate landscaping, and green features. Because of the proximity to the River Niger, I'm planning on having a water wharf, so that apart from the access roads which I have near to the site, I can always make use of the water body right here for transportation to the site. These are my floor plans for the design. On the ground floor, I have green areas all around the retail spaces that I have in place for people who want to rent spaces in the building. Then I have floor to top windows and doors. This is to help in capturing as much daylight as possible. And I have indoor pools for evaporative cooling. And at this area right here, I have the courtyard where I have green elements, and then on subsequent floors there will be voids which reach to the uppermost floor. This will help in serving as a wind tower, and heated air or hot air can rise up and go to it, and while cool air can come into the interior space. On the first and second floor, I have the commercial centers and then rentable office spaces and sports facilities on the second floor. On the third floor, I have the residence lounge and relaxation. Right here, I have two roof gardens where they can sit out to enjoy or to relax, and I have green elements all around it. Now, if you look closely, right here I have the double screen facade I was able to get in my research. The double screen facade will help in controlling the solar heat gain that will be coming into the building. As you can see right here, I have things the built-in architecture model I have developed for this design, things that can rotate and can be moved as needed to cool the interior space or to let in daylight. I have on the double skin facade, I have greenery whereby we have green elements that can be planted to help with the solar heat gain on the interior as well. Then on the fourth floor to the 18th floor, I have the residence apartments, which is I have two bedroom apartments on each floor, and as well I have the built-in architecture model I am proposing for this project, greeneries, and then the floor grills, which I will soon showing in my section. Here are the elevations for the project. On the front elevation, where I have the rentable spaces, the commercial spaces, there's metal grill or metal screens right here. This will help in reducing the solar heat gain in the interior spaces, while at the same time we still allow daylight to come into the building. Now on the rear elevation, as you can see, this section right here is where I have the residence areas. I have the written architecture model I'm proposing, showing right there. Then as you can see, the green elements which I'm proposing to have on each floor. Coming to the section right here, here is the wind tower. As I discussed earlier, here's the wind tower I'm proposing for the design. It goes from the ground floor up to the uppermost floor. Then on the section, I blew up the floor grill section I talked about earlier. Now, during the course of my research for this project, I came across a design that made use of these concepts. It employs the use of, it cuts holes on each floors, so in such a way, then it's covered with perforated grill sections in such a way whereby heated air or hot air can escape from the building. This is the site plan of the project, and as you can see, because for tropical climate, there's a rule for the building orientation. It is advisable in the tropical climate to orientate the longest part of the building along the north and south direction of the site. So I've done just that because doing this will allow you to have more daylight coming into your building while avoiding the direct impact of the sun rays as it travels from the east to the west. I tried as much as possible to reduce the ratio of the hard floor to the green areas, and here I have the parking lots which I've provided for people who are coming to work in the building or purchase things, and they will be making use of the parking lot temporarily. The blue line right here shows the bike track for cyclists who are coming into the building. Then there's the road that leads straight to the basement of the building. Now, looking at the case studies I've done, I've tried as much as possible to put some of the strengths I was able to find on those analyses in my home building. One of them is the solar panels which I have on my rooftop. Now, the general guideline, because there's a guide for placing solar panels on the roof. Now, for tropical climates, Nigeria to be specific, I discovered that To capture much of the daylight, it's advisable to face the solar panels to the south elevation. This will help in capturing as much daylight as possible and push the solar panels to its maximum efficiency. Then I have water collecting systems on the roof right here. I also have sit outs where people can sit and have a nice time and relax with while they enjoy the greenery around them. Then right here I have the WAF as I discussed earlier, which is supposed to be used, which is going to be used as an alternative transportation to the building. And sports facilities as well, because all work and no play makes Jack a dull boy. On this sheet, I'll be itemizing and pointing out the ecological features which I have on the site. Green landscape to serve as wind and solar breaks for the environment. Then how does it out for the gardens and for the gardens and the relaxation. Then I have details for the roof garden right here, which for the plants which I'm placing on the roof. And details for the solar panel, as I explained earlier, it has to be faced to the south elevation of the building, because this will allow you get more daylight to hit the solar panel surfaces and then maximize the efficiency. Now for the perforated floor grids, which I mentioned earlier, as I said, it's perforated and it allows hot air to rise up from lower floors to the upper floors, so that hot air can escape from the building while cool air comes in. Now for the written architecture model which I'm proposing for the site, because I'm of the opinion that users of a space are the best judge of how the space makes them feel. That's the reason why I'm proposing for this model to be manually operated, so that users on each floor can have total control on how they want to control the solar heat gain or the daylight coming into their spaces. As you can see right here, I'm showing that it can rotate with to block or to allow daylighting and increase solar heat gain should in case there is cold and you need someone in the interior space. Then in the next picture, as you can see, it can be closed and it can be moved, it can be slid like a sliding door type of mechanism, and it can be slid to cover up and create a cool and comfortable environment as well. This right here is the final sheet for this design, and I hope you can agree with me that it's a beautiful space. It's a beautiful environment to live in, and as you have the green features and the trees which serve as solar breaks, wind and noise breaks for the environment. And here you can see the green features I'm having on each floor, which is going to serve as a control for solar heat gain. And that's all. Thanks so much for your time.